Let's talk about using your Continuum as a DSP processor for incoming audio that you'll feed it through the AES digital I/O input. Now, half and full-size Continuums and newer Slim Continuums can support this feature. Continuum Minis unfortunately cannot. They can take a CV input signal but not an AES signal. So as long as we can get that digital signal into your Continuum, there's a wide range of processing you can do on it. In particular, we'll talk about using Eurorack inputs, but this can be any analog input as long as you can convert it from analog to digital and get it into your Continuum. Here's a list of some of the things that you can do with this signal. Basically, you can apply it like any other audio signal in the matrix to audio inputs. You can send that signal out the master section to apply recirculation, reverb echoes. You can apply convolution. You can do submix processing. The saturation processor in the master section can take effect if you need it to. And you can use the newer EQ processor that is included in post 9.0 firmware. You can use that input signal as a multiplier, for example, to create ring modulator-like effects. You can use that signal to modulate an oscillator, so it can be a modulation source. You can send it into any one of the simple filters, low pass, high pass, band pass, all the filters that you have available in your oscillator column. You can also use it as an input to the Big Bank and manipulate it in various ways with Big Bank properties. You can send it into the delay and use taps on it if you want. You can use it to excite the kinetic bank. You can input it to the sine bank. You can use it as an input to a bit graph or a bit mouth and manipulate it that way. You can even use it as an input excitation into the modal manipulator. This is more advanced, and you can use it on the live delay granular processing options in the ModMan. Again, a more advanced topic. We won't really get into those in this video. And finally, you can use it as a modulation input into the additive bank. In effect, you can see if you can get that audio signal into your Continuum, you have a massive number of things that you can do with it. Let's take a look at some of our options in terms of how we'll use this. There's basically 4 different ways that you can do this. If you have 2 Continuums, you can send the digital output of one right into the digital input of the other and manipulate the signal that way. You can have some analog source. Here, a Continuum Mini could be any analog source as long as you can get it into an A to D converter to convert to a digital signal to send into your Continuum, and then you can manipulate that analog source. Now, once you get it into the Continuum, you can either manipulate it so that you have no fingerboard processing used, basically use that Continuum as a DSP processor only, or you have the other option of using that DSP input along with the fingerboard inputs to do a lot of different things. We'll talk about these 2 in this video. And finally, if you have a 3 DSP processing Continuums, for example, all new Slim Continuums are 3 DSP 6X Continuums, and some older ones that have been upgraded have this feature too, you can create a combination preset and basically send the output of one standard preset where you're playing on the surface as an input into another where you'll process that digital signal in various ways. This kind of requires its own video on how to use combination presets. So if you have 2 half or full size Continuums, all you need to do to connect them to do this digital processing is connect an XLR digital cable between the 2. Always use digital cables when you're connecting things up here, not standard analog XLR or standard analog RCA cables. They may work, but you may have results that are less than optimal, so always spend a little extra money to give yourself a really good sound by using digital cables. Now, as long as the 2 Continuums are set to the same AES frequencies, you should be okay here. You can go into MIDI and global settings and always look at what your AES settings are for input and output. Now, you may have an older Continuum and a newer one, and you may want to connect those directly with the digital connection. Well, in that case, you'll probably need some kind of converter box. In this case, I use a host of CDL313 that can take an XLR digital input and convert it over to an RCA SPDIF output, or vice versa. And that's an easy way to connect up 2 digital systems in this manner. Again, we're not really going to talk about this in this video. So here's the more common method that you'll probably want to use. You'll have some kind of analog source, in this case a Continuum Mini, but it could be direct from your Eurorack, as we'll see in a bit. Now I send this through a direct input box, a DI box. It just turned out I had some noise in my system, and it's always a good idea to use one of these if you have it. Now this can perform some noise isolation, that's important. It also does impedance matching and can convert unbalanced to balanced signals. Normally you want to convert to balanced if your device does not directly put them out, because most of these D to A converters require a balanced input. And once I get that signal into my A to D converter, I will then connect it up to my Continuum, and in this case I have the newer Slim Continuum that takes the SPDIF RCA inputs. If you needed to connect up to XLR, you'd have to use one of those conversion boxes. But we want to talk about using Eurorack to get that into our Continuum. Well, very much the same thing. You'll have some kind of a Eurorack setup. The one we're going to use is going to be controlled by Continuums and Continuum Mini, so I'll need a CVC or a micro CVC to be able to get my Continuum to convert to CV that will drive my Eurorack system. That will connect up to your A to D converter, and that will go into your Continuum. Here I'm using the Haken Continuum voltage converter that can support up to 16 CV outputs. If you're using a Continuum Mini, I suggest you get micro CVC from Everton Technologies. Normally you'll be playing monophonically anyway. That's a much more cost-effective option for Continuum Mini. That will allow you to send your single set of CV signals to your Eurorack gear. You can get another one of these and connect two up, one a master, one a slave, if you want to support the full Continuum Mini two-voice operation. Of course, you don't have to use a Continuum to drive your Eurorack gear. You could have a very simple setup like this and use a MIDI keyboard controller to send to a MIDI to CV converter module, and from that you can send your CV signals around as you need them. At that point, you'll probably want to do something similar to what we just talked about. Use a DI box, maybe if you're not sending a balanced signal out of your Eurorack, go to your converter, go into your Continuum. But this is what we'll be doing for this video. We'll connect up both a Continuum Mini that will drive the UCVC, and I will connect that in such a way where I will control an Odessa additive oscillator. So I'll connect the Continuum Mini up. I'll send my 1 volt per octave output into the input of the oscillator. I'll send my Z output into a buffered mult where I can take 2 signals out from there and drive a VCA, because I'm going to want to send even harmonics to one of those channels and odd harmonics to the other and mix them together in a mixer. Then my Continuum, I'm going to use the Haken CVC, and that I will send out 4 channels of WXYZ, though in the video right now we'll only use X and Z. I'll use that to drive my Synthesis Technology E370 quad morphing VCO. So I'll be able to test polyphonic operation and monophonic operation. I'll send the Z outputs from that into a quad VCA so I can control each one of those voices independently in terms of Z envelope control. And I'll mix both of those oscillators together, and I'll send them out an output module through my DI box into the converter, and then send that digital signal into my Slim Continuum in this case, which I've got connected up to a mixer and my USB sound interface that'll connect up to the computer that's running my Eagan Matrix, where I'll show you how to program. Let's do some setup. I've brought up the empty preset. The first thing we want to do, if we have our A to D converter connected, is go to MIDI and Global Settings and make sure that AES shows input and output. You want to set your converter to the same value that you set here, and if you're not set up correctly, here I'll remove one. You'll get something like this that says no input. For things to work, you want to make sure that your input is set, your AES is connected. Now I can go through and check to see if my CVC is connected. I'm using that in this case, and it says CVC on F290, so my CVC is connected. I'll go in and I want to turn off my recirculator for now because I want to see what the signal sounds like dry. The new EQ tilt setting is set to off, so that won't be used. I don't have anything programmed into the matrix for convolution, so that won't be used. I should get a very dry signal from my Eurorack when I play it through the Continuum Mini here. Once again, if you're programming AES, make sure that you turn your volume down. If you don't know what you're doing, you can turn your levels down, and make sure you're not wearing headphones, because you can create a very loud sound and frankly hurt your ears if you're not careful. What I'm going to do to start, there's a setting here for audio in, that's my digital audio in. I will raise that a bit. I won't take it to full right now. I'll start off quietly and raise it as I know that I'm okay in volume. And now in my AES input, and I have two options here, I can program the left and the right on separate rows, or if I need perhaps to have more taps involved, I can have AES left and right on the same row. Well, we'll use this for now. What I'll do is start with a low volume, let's say 0.2. I have my A to D connected. Let me play something on the Continuum Mini. I get a very dry signal. Well, I can raise the volume a little bit on the input. And I might want to even raise this a bit, say to 0.4. So I've used a constant here, and basically all I'm doing is I'm sending the AES signal right into the master section. So anything that will apply to the master section can be applied to this signal. The first thing I want to do is see what happens if I turn on my recirculator. And I can hear the recirculator's on now. I can go all the way wet. I can try and apply different recirculator types. Let's say swept echo. You can hear that went on for quite a long time. I can reduce my feedback in time if I want. You can play around, and any of the recirculator options that you'd have available normally in the matrix you can apply direct to the AES here, with basically no programming whatsoever, just applying a constant there. Or I could use a constant formula too. Now, one thing to note is when you use a constant or constant formula on the AES input, AES feeds into all voices. So if you have a constant or a constant formula, it opens up all the voices to pass through. Basically, the more polyphony, the more voice copies you create, and the result will be, as polyphony is increased, your volume will increase. Well, let's go in here, set ourselves back to digital reverb, set our bass polyphony, set it to bass 1. Let me set this a little louder, and I'll play a note. Let me raise that now to bass 6. Same pressure. You can hear it's louder. It's affecting more voice copies. Well, what if you're writing a preset and you want it to have basically a similar sound no matter what polyphony you're using? What we can do here is use a polyphony scaler. Scaling is a whole nother video, and a very important one at that. But for this particular case, let's define a constant, and we'll set that to 0.5 instead of the constant 0.5. Should give us a very similar effect. If I go and now raise my polyphony to 8, say, you can hear that I've increased the volume there. Let me put a polyphony scaler on this instead. To see what that's doing, let's take the formula. We'll stick it somewhere where it's not going to have an effect. And I'll say polyphony scaler on this. I'll show formula value. I have to press the fingerboard because you can't display formulas without pressing the fingerboard. But in this case, let me set for polyphony 1, and this scales according to polyphony. Let's set this to 1, it's easier to see. I'm set bass 1. Let's play a note. I'm not sending anything to output so you can't hear anything, but the formula is displayed as 1. Let me set this to bass 2 now. Now it's 0.5 because it's scaled 1 over polyphony, which is 1 over 2. I could go to bass 4, and now I'm scaled 0.25, as would be expected. Well, what this can do for me, obviously, is scale to my initial volume now, and as I increase polyphony, I should remain relatively constant on volume. Let's give that a shot. Let's stick our formula back on the AES row. Well, let's keep it at the unity value. Set our base polyphony to 1. Play a note. Now let's set this to base 8 and see what the difference is. Before there was a very noticeable change in volume. Now it's very consistent. Polyphony scaling can be used all over the place to help even out things based on polyphony, like we did here. Using it on delays is common, for example. You can scale on other things. You can scale on a voice number. You can scale on the number of fingers you're playing. But in this case, scaling on polyphony is really what we want to do to keep that volume more or less consistent, if that's what you want. So there's the simplest way of using AES. Just channel it right to the output. I can bring in EQ. If you want to use that, here's another preset I have, program some convolution based on pressure and your first bespoke control. You can hear that's kicking in. I can go through different convolution types. I can change the amount of convolution with this other formula. Some convolutions will give you a higher volume than others, so you can play around. Now let's take a look at taking this one step further. Now we're going to apply the AES input to components in the Eagan Matrix, and this is where things really start to get interesting and fun. Remember, our basic setup is the Continuum Mini through the micro CVC is playing one Eurorack sound module. The Continuum through the Haken audio CVC is playing another sound module. Those are mixed together, sent through a D to A converter, and the output is sent as the digital input to the Continuum, where we're going to apply our DSP Eagan Matrix processing to it. Now, as long as I only use constants in my formulas in the matrix, I'm not going to be applying any finger data of the Continuum to my formulas. We'll do that in a little bit, but right now we'll still use constants. Instead of sending the AES input direct to the master section, we're going to remove it. And what we'll do instead, in this case, we'll use a multiplier. With the multiplier, we can get ring modulator-like effects. So we'll send the unity amount of that signal as one of the operators of the multiplier. Since it's a multiplier, if we don't have anything assigned to the second input, we're not going to get any sound out of that multiplier. What we'll do as a simple case is we'll take an oscillator in the Eagan Matrix. We'll set that to a fixed frequency, 220 Hertz, and we'll send that as the other input to the multiplier. The output now of position 1, that multiplier, I'm going to send to my master section. Now remember, I know what I'm doing here. If you're doing this, make sure to turn your volume down. Don't use headphones. And I would start by using fractions here, not whole numbers, just to be on the safe side. Now, when I play my Continuum Mini, I will in effect be multiplying that with a fixed 220 Hertz sine wave, and I should get some kind of ring modulator-like sound out. That's exactly what happens. What if I play the Continuum? That's playing the other sound module, and I get a very similar sound out. So I'm basically using my Continuum as a DSP ring modulator in this case. Just to prove to you, we'll take off that, and let's go back to outputting the direct AES signal. There you can hear that ring modulation like effect is no longer applied. Well, this is all very nice, but somewhat limiting. What would happen, say, if I go back and instead of using a fixed oscillator, I'll put X on that. Well, now we're going into a very different realm. Now, when I play the surface, I'm both sending the output of my Eurorack sound module as the input into the continuum, but also controlling that oscillator's frequency on the continuum itself. And this is probably more the model you'll want to work with, because not many people have both a Continuum Mini and a Continuum. If you have a Continuum, you can use it as both your controller for your Eurorack, feeding in simultaneously and controlling Eagan Matrix components at the same time. So now when I play, now I can get a more dynamic ring modulator effect because I'm not just sending in one fixed frequency. This is the start of us being able to do some pretty fantastic things now by combining Eurorack and Continuum with DSP processing on the digital input. Let's end part one of this discussion by looking at the other option of AES input. Instead of putting them both on the same line, where I'm kind of mapping the left and right channels together, I can define it so that my AES channels are processed independently. Now I can do some really cool things with this. I went to the Eurorack and I turned one processor all the way to the left on panning and the other all the way to the right. There's a little bleed through, but this serves the case well. I'll send the left channel into the multiplier on one input and the right channel into the multiplier on the other input. So one channel is going to come out when I play the Continuum Mini, and the other channel will come out when I play the Continuum, both mixed together, sent back in to the Continuum for DSP processing. If I play any one of these, I'm not going to hear anything because I need them both multiplied against each other to get a sound. But now if I play them both at the same time, I'm basically ring modulating the left and right channels together. That's pretty cool. You can do this and so many more wonderful things once you get the hang of this kind of a setup.